Hello students, we are going to discuss decision support system. This is the structure for the block. We are going to cover DSS topic, concept and philosophy, types of DSS, example of DSS, after that deterministic system, followed by AI system, application of AI system, KVES, next we have MIS and the role of DSS, role of MIS and DSS in decision making. After that, TPC, functions of TPC, enterprise management system, types of EMS, followed by function of EMS, enterprise resource planning system, benefits of ERP, and then EMS and ERP. So our first topic is DSS. DSS is also known as decision support system. It is a type of computer program that helps companies make better decisions. Think of it as a smart assistant that processes a lot of information and then suggests the best choices available. Now I will explain how it works. The DSS collects and examines huge amount of data from various sources within the company. Based on this analysis, the system identifies different possible decisions the company can take. Finally, it presents these options to the decision makers, highlighting the most beneficial one. For example, if a company needs to decide on a new marketing strategy, a DSS can analyze past sales data, current market trends, and customer preferences. Then it will suggest the strategies that are most likely to succeed. In simple terms, a DSS helps companies make smarter, data driven decisions by turning complex data into clear, actionable options. So, why we are studying DSS? What is the purpose behind it? DSS produces detailed information reports by gathering and analyzing data. Hence, a DSS is different from a normal operations application whose goal is to collect data and not analyze it. In an organization, a DSS is used by the planning departments such as the operations department, which collects data and create a report that can be used by managers for decision making. Mainly, a DSS is used in sales projection for inventory and operations related data and to present information to customers in an easy to understand manner. A DSS can be employed in various knowledge domains from an organization to forest management and the medical field. One of the main applications of a DSS in an organization is real-time reporting. It can be very helpful for organizations that take part in just-in-time, which is called JIT inventory management. In a JIT inventory system, the organization requires real-time data of their inventory levels to place orders just in time to prevent delays in production and cause a negative domino effect. Therefore, a DSS is more tailored to the individual or organization making the decision than a traditional system. Here we are going to discuss concept and philosophy of DSS. The process of making decisions using a DSS is not always straightforward. The criteria for choosing the best solution can change depending on the specific problem. This means that the decision making process often needs to be repeated multiple times until a satisfactory solution is found. Let's break this down because different problems require different criteria. We might need to go through the three phases: intelligence, design, and choice more than once. Each cycle helps refine our understanding of the problem and improve our solutions. We ask questions and gather information to deepen our understanding of the problem. Then we analyze the data to identify patterns, trends, and insights that can guide our decisions. Then we use various models or accounting systems to simulate different scenarios and evaluate potential solutions. By repeating these steps, we can systematically approach complex problems and work towards rational, well-informed solutions. All in all, the DSS process is iterative. We may need to cycle through the phases of intelligence, design, and choice multiple times, using tools like inquiry, analysis, and models to find the best solutions. A DSS is designed to assist in the decision making process. It's important to understand that a DSS supports decision makers but does not always make decisions on its own. Here are some key points to consider, like the DSS provides valuable insights and data, but the final decision is still made by a human. The system helps by offering information, options, and recommendation, but it doesn't replace the decision maker. When making decisions, especially similar or repeated ones, the decision maker needs access to a variety of information. This can include historical data, current trends, forecast, and more. The nature of decisions can vary greatly, requiring different types of information each time. The DSS is versatile, capable of providing diverse data to help address various decision-making scenarios. DSS is a tool that aids decision makers by supplying comprehensive and relevant information. It enhances the decision making process but leaves the final judgment to the human user. DSS is a specialized type of information system specifically designed to assist managers in making decisions, particularly in situations that are semi structured or unstructured. Let's break this down. A DSS is interactive, meaning it allows managers to engage with the system, input data, and receives feedback. This interaction helps tailor the decision making process to the specific needs of the situation. Unlike routine, well defined problems, semi structured and unstructured situations are more complex and less predictable. These scenarios do not have clear step-by-step solutions, and that's why a DSS shines. The DSS gathers and processes data from various sources within the organization. It uses different models such as statistical, financial, or simulation models to analyze data and predict outcomes. These tools help in organizing, sorting, and interpreting data to make it more useful for decision making. At the end, a DSS helps managers navigate complex and certain situations by providing them with the necessary tools and information to make informed decisions. Here are some benefits of DSS. First point is enhanced decision making quality. DSS provides detailed data analysis which helps in understanding complex business scenarios. This leads to more informed and accurate decisions. By removing guesswork, DSS ensures that decisions are based on solid data rather than intuitions. DSS allows businesses to simulate different scenarios and predict outcomes. This helps in evaluating the potential impact of various decisions before they are made, reducing the risk of negative consequences. Second, we have time efficiency. DSS can quickly analyze large data sets, providing timely insights that are crucial for making prompt decisions. This is particularly beneficial in fast-paced industries where time is a critical factor. DSS automates the generation of reports, which saves time and reduces the burden on employees. This allows them to focus on more strategic tasks rather than routine data analysis. Next, we have improved resource management. By analyzing data on resource uses and availability, DSS helps in optimizing the allocation of resources. This ensures that resources are used efficiently and effectively, leading to cost savings and improved productivity. DSS can track inventory levels in real time, helping businesses maintain optimal stock levels and avoid overstocking or stockouts. Next point is enhanced operational efficiency. DSS analyzes business processes as a whole rather than in silos. This holistic approach helps in identifying inefficiencies and areas for improvement. Leading to streamlined operations, DSS provides real-time monitoring of key performance indicators, which is called KPIs, enabling businesses to track their performance and make necessary adjustments to improve efficiency. Next point we have better problem solving. DSS can handle complex problems by breaking them down into manageable components and analyzing each part. This helps in identifying the root cause of issues and developing effective solutions. DSS supports long term strategic planning by providing insights into market trends, customer behavior, and competitive dynamics. This helps businesses develop robust strategies for future growth. Next point we have increased accessibility and collaboration. DSS centralizes data from various sources, making it easily accessible to all relevant stakeholders. This promotes collaboration and ensures that everyone is working with the same information. Many DSS are internet based, allowing decision makers to access the system from anywhere at any time. This enhances flexibility and ensures that decisions can be made even when team members are not physically present. Next point is competitive advantage. By providing accurate and timely information, DSS helps businesses stay ahead of the competition. Informed decisions lead to better business outcomes and a stronger market position. DSS enables businesses to quickly adapt to changing market conditions by providing real time insights and predictive analytics. This agility is crucial for maintaining a competitive edge. Last point is cost savings. By optimizing resource uses and improving operational efficiency, DSS can lead to significant cost savings. This includes reducing waste, minimizing downtime, and improving overall productivity. DSS helps in identifying potential risks and issues before they become major problems, thereby avoiding costly mistakes and ensuring smoother operations. Here are some limitations of DSS we are going to discuss. The very first one is dependence on quantifiable data. While DSS offers numerous benefits, here are some limitations of DSS. While DSS offer numerous benefits, they also come with certain limitations that can impact their effectiveness. Understanding these limitations are crucial for businesses to make the most out of their DSS implementations. Here are the detailed limitation of DSS. The very first one is dependence on quantifiable data. DSS primarily relies on quantifiable data, which means it can struggle to analyze intangible or qualitative data. For example, factors like employee morale, customer satisfaction, and brand reputation are difficult to quantify but can significantly impact business decisions. Some aspects of business operations cannot be fully captured in numerical terms. This limitation can lead to incomplete data representation This limitation can lead to incomplete data representation and potentially flawed decision making. Next point we have assumptions and biases. Decision makers may not always be aware of the assumptions that a DSS has made during data analysis. These assumptions can influence the outcomes and recommendations provided by the system. If these assumptions are incorrect or not fully understood, they can lead to misguided decisions. Although DSS aims to reduce human bias, the system itself can introduce biases based on the data it uses and the algorithm it employs. For instance, if the input data is biased, the DSS output will also be biased. Next point we have complexity and cost. Implementing a DSS can be expensive, involving significant costs for software, hardware, and training. Additionally, maintaining and updating the system can incur ongoing expenses. DSS can be complex to use, requiring specialized knowledge and training. This complexity can be a barrier for some users, particularly those who are not tech savvy. Next point we have data quality and integration issues. Data quality and integration issues. The effectiveness of a DSS is heavily dependent on the quality of the data it uses. Inaccurate, outdated, or incomplete data can lead to incorrect analysis and poor decision making. Integrating DSS with the existing systems and databases can be challenging. Inconsistent data formats and incompatible systems can hinder the seamless flow of information, affecting the DSS's performance. Next point is over-reliance on technology. Over-reliance on DSS can lead to a reduction in human judgment and intuition in decision making. While DSS provides valuable insights, it should complement rather than replace human decision making capabilities. Like any technology, DSS is susceptible to technical issues and system failures. Dependence on DSS means that via downtime, DSS means that any downtime or malfunction can disrupt decision making processes. Next point is security and privacy concerns. DSS involves handling large volume of sensitive data, which can be target for cyber attacks. Ensuring robust security measures is essential to protect data. Next point is security and privacy concerns. DSS involves handling large volume of sensitive data which can be target for cyber attacks. Ensuring robust security measures to essential to protect data integrity and confidentiality. The use of personal and sensitive data in DSS raises privacy concerns. Businesses must ensure compliance with data protection regulations to avoid legal and ethical issues. Last point is limited scope. Some DSS are designed to address specific problems or areas within a business. This narrow focus can limit their applicability to broader or more complex issues. DSS may lack of flexibility to adapt to rapidly changing business environments or unique situations that fall outside the predefined parameters of the system. So here are some types of DSS we are going to discuss. One type of DSS is the status inquiry system. This system is particularly useful for decisions that don't require complex analysis or computations. Many decisions at the operational management level and some at the middle management level are straightforward and based on specific aspects of a situation. These decisions are often routine and repetitive. Decisions made using a status inquiry system rely on knowing the current status of certain variables or conditions. One of these status is known, the decision becomes clear and straightforward. There is no need to elaborate analysis or choices. The relationship between the status and the decision is unique. If a particular status is identified, the corresponding decision is automatic. For example, if a warehouse manager wants to know if the stock level of a product are low, the status inquiry system can quickly provide this information. If the stock is low, the automatic decision is to reorder more stocks. All in all, a status inquiry system simplifies decision making by providing the current status of specific variables, leading to automatic and straightforward decisions without the need for complex analysis. Another type of DSS is data analysis system. This system is designed for decisions that require comparative analysis and the use of formulas or algorithms. These systems perform comparative analysis, which means they compare different sets of data to find patterns, trends, or discrepancies. For example, comparing current sales data with historical data to identify growth or decline. Data analysis systems use specific formulas or algorithms to process and analyze data. These processes help in making decisions based on the analyzed data, such as calculating cash flow or inventory levels. Unlike routine processes, the analysis involved in these systems is not always structured. It can vary depending on the specific situation and data requirements. This flexibility allows the system to adapt different decision making needs. Here are some examples of data analysis system. The first one is cash flow analysis, which means analyzing the inflow and outflow of cash to ensure there is enough liquidity for operations. Next point we have inventory analysis, examining inventory levels to optimize stock management and avoid overstocking or stockouts. Next point, personal inventory systems, which means managing personal or employee related data such as attendance, performance, and resource allocation. Last point we have tools and business rules, which means developing a data analysis system requires simple data processing tools and business rules. These tools help organize, process, and analyze the data according to predefined business rules. All in all, a data analysis system supports decision making through comparative analysis and the application of formulas or algorithms. It is flexible and adaptable to various unstructured decision making processes. Another type of DSS is information analysis system that focuses on analyzing data and generating informative reports for decision making. In this system, raw data is thoroughly analyzed to produce detailed information reports. These reports provide insights into various aspects of the business or situation under consideration. Reports generated by information analysis systems often include exceptions highlighting unusual or significant data points. Exception reporting helps decision makers quickly identify areas that requires attention or further investigations. Decision makers use the information reports to assess the current situation and make informed decisions. The detailed analysis and highlighted exceptions in the reports provide a comprehensive view, aiding in better decision making. Here are some examples of information analysis systems like sales analysis, which means analyzing sales data to understand performance trends, identifying top selling products, and spot areas needing improvements. Another point we can take accounts receivable systems, which means managing and analyzing outstanding customer invoices to ensure timely payment and manage cash flow. Another point we can take market research analysis, examining market research data to understand consumer behavior, market trends, and competitive landscape. One more point we can include in this type of system is material requirements planning system, which is also known as MRPS, which means analyzing inventory levels and production schedules to ensure materials are available for manufacturing processes. In summary, we can say information analysis system generate detailed reports from analyzed data, including exceptions to support decision makers in assessing situations and making informed decisions. Another type of DSS is accounting system. In DSS, this type of system are not primarily designed for decision making. They play a crucial role in tracking and managing essential business aspects. The purpose of behind this type of system are primarily used to keep track of the major aspects of a business or function. They ensure accurate and organized recording of transactions and data, which is vital for the overall management of the organization. Accounting systems focus on data processing, produce formal reports. These reports may include exceptions to highlight any deviations from the norm, providing valuable insights for management. The systems account for crucial items such as cash, inventory, and personnel. By continuously tracking these items, the system helps maintain control and ensures that everything is aligned with the company's goals and standards. The data recorded and processed by these systems is often compared to norms or standards developed by management. This comparison helps in maintaining control and can assist in decision making when deviations from the norms are identified. Example, we can take first point is cash accounting systems, which means track cash flow to ensure proper management of incoming and outgoing funds. Next, we can take inventory accounting systems, which means monitor inventory levels to manage stock efficiently and prevent overstocking or stockouts. We can take personnel accounting systems as an example, which means keep track of employee related data such as payroll, attendance, and performance. All in all, accounting systems are essential for tracking and managing the major aspects of a business. They focus on data processing and formal reporting, helping maintain control and providing a foundation for informed decision making. Another type of DSS is model based systems. These type of systems that utilize models for simulation and optimization to assist in decision making. These systems use simulation models to mimic real world scenarios, allowing decision makers to test different strategies and see potential outcomes. Optimization models help find two best possible solutions to a problem by maximizing or minimizing certain variables. The decisions supported by model based systems are often one-time and infrequent. These decisions typically provide general guidelines that can be applied to various operational or management situations. Here are some examples of model-based systems like product mix decisions, which means determining the optimal combination of products manufactured to maximize profit or minimize cost. Another example we can take material mix, which means identifying the best mix of materials to use in production to ensure cost effectiveness and quality. Another example we can take job scheduling rules, which means developing rules for scheduling jobs in a manufacturing process to optimize efficiency and reduce downtime. Planning the use and allocation of resources, assets, or facilities to ensure optimal utilization and strategic management. All in all, model-based systems use simulation and optimization models to support decision making for one-time, infrequent, and strategic decisions. They provide general guidelines that help improve operations and management. Here are some examples of DSS. We will discuss each of the example. The first we have finding and selection of vendor. This decision requires an inquiry system to gather information about potential vendors and evaluate their suitability for the organization's need. Next we have procurement. The procurement process involves various activities such as preparing requirements, evaluating vendors, and selecting the most qualified ones. To analyze the performance of vendors, a performance analysis system is needed. Next, we have pricing. To analyze pricing information and make informed decisions, a data analysis system is required. Another point is selection of vendor based on price, quality, and performance. This decision requires an information analysis system to compare and evaluate vendors based on multiple criteria such as price, quality, and performance. Next, we have selection of order quantity. To determine the optimal order quantity, a model-based system is needed. Next, inventory rationalization. This decision involves the valuation of inventory and requires an inventory and accounting system to track and manage inventory management of inventory within various financial and stocking constraints to optimize inventory levels considering financial and stocking constraints. An inventory optimization model is required. Here are few successful examples of DSS implementation. The very first one is agriculture. The decision support system for agrotechnology transfer is a prime example of a successful DSS in agriculture, developed with the support of USAID during the 1980s and 90s, which is also known as DSSAT4, has facilitated rapid assessment of agricultural production systems worldwide. The system helps in decision making at both the farm and policy levels by tailoring decisions to specific portions of farm fields, thus enhancing precision agriculture practices. Next, we have marketing. In the dynamic field of marketing, DSS are indispensable for crafting and implementing effective strategies. These systems delve into marketing dynamics, consumer behavior, and campaign performance analysis, providing a nuanced understanding of prevailing market trends. This allows organizations to tailor their marketing strategies with precision, enhancing the impact of their campaigns. Next, we have healthcare. In the healthcare industry, a Silicon Valley high-tech company implemented a hybrid distributed reporting system using multiple SQL Server technologies such as data replication, database mirroring, and database snapshots. This complex application environment supports healthcare decision making by optimizing data management and accessibility, thereby improving patient care and operational efficiency. Next example is corporate finance. A DSS used in corporate finance can project a company's revenue over the upcoming months based on new assumptions about product sales. This application is crucial for financial planning and strategy as it allows companies to make informed decisions based on projected financial outcomes considering a large number of influencing factors. Last point we have manufacturing. In manufacturing, intelligent or smart manufacturing system represent a form of DSS as an intelligent decision support system, which is also known as IDSS. These systems integrate machine learning, data mining, and a knowledge base to optimize manufacturing processes by evaluating human decision making capabilities efficiently. These systems enhance operational efficiency and product quality. These examples illustrate the broad applicability and success of PSS across different sectors, whether optimizing agricultural outputs, enhancing marketing strategies, improving healthcare delivery, forecasting financial outcomes, or streamlining manufacturing processes. DSSs provide critical support that enhances decision making and operational efficiency. Each implementation showcases the ability of DSS to adapt to specific industry needs and contribute significantly to organizational success. Our next topic is deterministic systems. These are the type of DSS where outcomes are precisely determined through known relationships among states and events, without any room for randomness or unpredictable behavior. In the context of DSS, deterministic systems are used when management needs to make decisions based on the analysis of business statistics. Since organizations maintain databases with various type of information, these deterministic decision situations draw data from these databases. This data is then used to analyze and make informed decisions. Most of these decision situations are fairly structured, meaning they follow a specific predictable pattern. Therefore, they can be represented in the form of business models. These models help in understanding the potential outcomes of a particular decision. A fair assumption is made that the model used in these deterministic systems has business and decision making validity. This means that the model is assumed to accurately represent the business situation and can be used to make valid decisions. DSS, including deterministic systems, are primarily used by mid to upper level management to compile information and data and to synthesize it to actionable intelligence. They help in making more informed decisions at a quicker pace. Model driven DSS allows users to analyze and manipulate specific models of data. They analyze scenarios and data to allow the user to manipulate a model, such as creating a work schedule. They might use simple analysis tools or complex statistics depending on the model's purpose and user's need. The slide extends the discussion on deterministic decision support system and emphasizes the importance of custom designed models. Here is a detailed explanation. If management can design and duly test these business models, they can be utilized by decision makers whenever a need arises. The model should be designed in a way that accurately represent the business problem or decision scenario and should be thoroughly tested for validity. These tools and models act as support system for decision making. They help in organizing data, analyzing potential outcomes, and providing recommendations. While the tools and models used in deterministic DSS are generally standard, they need to be customized to suit the organization's specific needs in a specific situation. This implies that although the fundamental principles of the model remain the same, their parameters and variables are adjusted to fit the unique characteristics of the business situation at hand. The customizations ensure that the decision support system is aligned with the organization's objective, data infrastructure, and decision making processes. This is crucial for the DSS to provide relevant and actionable insight. The custom designed model can thus be used in various decision making situations from resource allocation to strategic planning and can significantly enhance the quality of decisions by providing data driven insights. The slide discusses the widespread use of DSS tools and models, their cost effectiveness, and their adaptability across various hardware systems. DSS, particularly those based on deterministic models, have found extensive use in various industries. This is due to their ability to assist in decision making by providing data driven insights and facilitating scenario analysis. Here is mentioned that a number of computer based software tools and packages for DSS are available at a very reasonable price. This makes them accessible for businesses for all size, contributing to their widespread use. These DSS packages are hardware independent, meaning they can operate on various type of computer systems, from personal computers to mainframe computer systems. This flexibility allows organization to implement DSS solutions regardless of their existing hardware infrastructure. The slide also mentioned that DSS packages are available for popular network systems. This means that these systems can be integrated into an organization's existing network infrastructure, facilitating data sharing and collaboration. DSS tools and models have proven their utility in various application areas such as financial planning, scheduling, and inventory management, among others. So, here is a case study on DSS which we are going to study. This case study examines how a large retail chain successfully tackled inventory management challenges by implementing a cloud-based DSS. The company's previous system struggled with the inaccurate forecasting, leading to both overstocking and understocking, which increased costs and hurt customer satisfaction. The new DSS integrated data from various sources using advanced analytics to forecast demand, automate replenishment, and optimize stock level across all stores. This resulted in reduced inventory cost, increased sales, and improved customer satisfaction. However, the company faced challenges with data quality and change management during the implementation process. Overall, the case highlighted how a well implemented DSS can significantly improve operational efficiency and strategic decision making in a retail environment. So here are the some questions. You can take a screenshot and find out the answers of these questions. Although I will discuss one by one. So our first question is, what were the key challenges faced by the retail chain before implementing the DSS? The retail chain faced a dual challenge in its inventory management. The first one was overstocking, as I have already mentioned. Ordering too much inventory tied up capital in unsold goods, incurred unnecessary storage cost, and increased the risk of product spoilage, especially for perishable items. The second point was understocking, not having enough of a product when customer demanded it led to lost sales opportunities, frustrated customer, and potential demand, or we can say potential damage to the brand's reputation. Their existing system lacked the sophistication to find the balance between these extremes, relying on manual processes and historical data that couldn't keep up with fluctuating demand patterns. Next question we have, how did the DSS help the company overcome these challenges and improve its inventory management practices? The DSS brought several key improvements like data integration. It combined data from various sources like POS, warehouses, market trends to provide a holistic view of inventory status and demand signals. Second, we can say accurate forecasting. The system's algorithms could identify complex pattern and predict future demand with greater accuracy than manual methods, considering factors like seasonality, promotions, and even local events. Next point we can take automation. Replenishment became proactive with the DSS automatically generating purchase orders based on real time data, ensuring stores received stock when they needed. Next, we can take optimization. Instead of a one size fits all approach, the DSS calculated optimal stock levels for each product at each store, minimizing waste and maximizing sales potential. Our next question is, what specific functionalities of a DSS contributed to the positive outcomes achieved by the company? So there are several functionalities were critical, like demand forecasting. Accurate predictions formed the foundation for all other improvements, enabling the system to anticipate needs. Second point we can see over the slide, like automated replenishment, which means this streamlined the supply chain, reducing delays and ensuring stores had the right products on hand. Next, we have inventory optimization. By fine tuning stock levels at the granular level, the company minimized unnecessary holding costs and reduced the risk of both overstocking and stockouts. Next point is performance dashboards. So, providing managers with real time visibility into inventory performance allowed for data driven decision making and quick responses to emerging trends or issues. Our next question is, what were some of the challenges encountered during the implementation of the DSS and how might these challenges be addressed? This study highlighted two common challenges. First one is data quality. Second one is change management. How? We will discuss. The first point is data quality, which means inaccurate or inconsistent data from different sources could lead to flawed decisions by the DSS. This can be addressed through data cleaning and validation process, ensuring data sources are reliable and integrated seamlessly. Second, we mentioned change management. So people are often resistant to change, moving from manual experience based inventory management to a data driven system require training, communication, and demonstrating the benefits to employees, focusing on user friendly interfaces and providing ongoing support can ease the transitions. Next question is, how can the retail chain further leverage the capabilities of the DSS to enhance its operations and competitiveness in the future? Yes. So the retail chain can take several steps. First step is predictive analytics, like go beyond forecasting demand to predict broader trends such as shift in customer preferences or the impact of external factors like economic conditions. Next point is personalization. Use the DSS to tailor inventory and promotions to specific customer segments based on their purchase history and preferences. We can take supply chain integration also, which means connect the DSS with suppliers to further optimize the supply chain, enabling just in time inventory management, which is also known as JIT inventory management, and reducing lead times. Last but not the least, continuous improvement. Regularly evaluate the DSS's performance, identify areas for improvement, and incorporate new data sources and technologies as they become available. By continuously evolving its DSS capabilities, the retail chain can stay ahead of the curve, maintain a competitive edge, and ensure long term success in a dynamic market. I hope all the question and answer were cleared. Next topic we have AI system, which is also known as artificial intelligence system. You know how we humans use our brains to solve any problem, right? We use our knowledge and reasoning abilities to figure things out. Now imagine if we could make a computer do the same thing. That's what artificial intelligence or AI is all about. It's like packing a human like intelligence into a computer system. AI is a broad field of computer science focused on creating systems capable of performing tasks that would typically require human intelligence. These tasks include learning, reasoning, problem solving, perception, and language understanding. AI systems are designed to handle tasks ranging from simple, specific applications to complex and multifaceted challenges across various domains. One of the significant shifts in AI development is the move from domain specific systems to more generalized platforms. Foundation models, for instance, are trained on vast diverse data sets and can be fine tuned for various tasks across different fields. This adaptability allows them to learn and function in multiple domains, making them incredibly versatile and powerful. AI systems integrate various forms of technology, including machine learning, which is called ML, deep learning, and neural networks. Machine learning algorithms enable AI systems to learn from the make decisions based on data. Deep learning, a subset of ML, uses layered neural networks to analyze various factors of the data. These technologies allows AI to handle multiplex data inputs and deliver outputs that can be incredibly accurate and increasingly reliable over time. AI is also characterized by its ability to improve over time. As AI systems are exposed to more data, they learn and adapt, enhancing their accuracy and efficiency. This feature is particularly evident in areas like voice recognition and image processing, where AI systems learn to improve their understanding and response accuracy as they process more inputs. Ethical and operational considerations are crucial in AI deployment. As AI technology becomes more pervasive, issues such as privacy, security, and bias gain prominence. Ensuring that AI systems are used responsibly involves addressing these ethical concerns, maintaining transparency, and managing the potential impacts on employment and societal norms. AI's applications are vast and growing. In healthcare, AI can diagnose disease, suggest treatment, and manage patient data. In business, it can optimize operations, predict consumer behavior, and enhance customer service. And also in our automotive industry, AI is at the heart of autonomous driving technology. Each application notifies and systems ability to handle specific tasks, often outperforming humans in speed, accuracy, and efficiency. And application of AI we will going to discuss after the whole topic. The development of AI has not been without challenges. Issues such as explainability, where users seek to understand how AI make decisions, are significant hurdles. Explainable AI aims to make AI's decision making process transparent and understandable to humans, ensuring that AI systems are accountable and their actions justifiable. AI system comes in three main types. First, there are expert systems, which are like the know it alls of the AI world. They are packed with knowledge and can make decisions based on that. Then they are natural language systems. These are the ones that can understand and generate human language. Think of your phone's voice assistant, for example. Lastly, there are perception systems. These are the ones that can understand things like images, speech, and even touch. AI is like a special kind of software. It's not just about crunching numbers, it's about understanding symbols, statements, and patterns. It's about reasoning and problem solving, and it's finding its way into all sort of areas, from designing things to diagnosing problems, planning, scheduling, and even forecasting. But here is the thing: AI systems are not here to replace us, they are here to help us. They take care of the simple, common problems, leaving us free to tackle the more complex ones. They help us avoiding making the same mistakes and respond quickly to new problems. One special kind of AI system is the KBES, which is known as Knowledge Based Expert System. It used a lot in business and industry, and all these AI systems thrive on AI. AI is like a melting pot of knowledge from different fields like computer science, biology, psychology, maths, statistics, and engineering. The goal is to make computers as smart as human, able to reason, learn, solve problems, be creative, and respond quickly. AI is a big field. and it's finding its way into all sort of areas in business and industry. For example, cognitive science uses knowledge and human information processing capabilities to create expert systems. These systems can provide advice to decision makers just like a human expert would. Another example is robotics. Here, AI is used to guide machines to perform like humans, with capabilities like perception, touch, manipulation, and even navigation. This is really useful in areas like manufacturing and transportation. Then there is the natural interface application. This uses AI to create a natural, realistic, multisensory interaction between humans and computers. It's like creating a virtual reality. This can be really, handy when you want to test or experience something before it's actually created. For example, an architect can use virtual reality to see different views of a house before it's built. So, in a nutshell, that's what AI is all about. It's about making computers think and solve problems like humans do. And its findings its way into all sort of areas, helping us solve problems and make better decisions.